Moving on to another communication question. So if a function has an absolute maximum or minimum, is it an odd degree or even degree function? Okay, so let's start this question off by showing the diagrams for the possibilities of the n behaviors for an odd degree function. So if the leading coefficient is positive, so if leading coefficient is greater than 0, then we know the n behaviors are going to be what? From quadrant 3 to quadrant 1. And then if the leading coefficient is negative, it's going to be what? From quadrant 2 to quadrant 4, like that. And then let's do the same thing for an even degree function. Okay, so an even degree function, if the leading coefficient is positive, so we'll put that more in the middle. So basically, this is for both of these graphs. If the leading coefficient is positive and it's an even degree, n behaviors are like this. And then if the leading coefficient is negative for an even degree, n behaviors are like that. Okay, so which of these scenarios here can have an absolute maximum or minimum? Well, if you notice in this first scenario, the function at some point as x goes to infinity, the y values are going to go to infinity as well. So notice how this function, this scenario, is never going to have an absolute maximum, because the function is going to keep increasing as x goes towards positive infinity. Same thing as x goes towards negative infinity. The function is going to keep decreasing, or the y values are decreasing rather, as x goes towards negative infinity. The function's still increasing because we read from left to right, but as x goes towards negative infinity, the y values are going towards negative infinity as well, so there's no absolute minimum here. So we know this case doesn't work. What about this case? Well, same thing. As x goes towards negative infinity, the y's goes toward positive infinity. So we know here there can never be an absolute maximum, meaning that there's a point at which the function hits and there's no other y values that are greater than that. The y values are going to keep going towards positive infinity. Here they're going to keep going towards negative infinity. So there's not going to be an absolute minimum here either. So that won't work. What about for these scenarios? Well, notice that for an even degree with a leading coefficient that's positive, there's always going to have to be some kind of absolute minimum somewhere. So let's say it's here in this case. Why is that? Well, because the function has to turn back, because it goes from quadrant 2 to quadrant 1 at some point. So whether it has a bunch of turning points and then it hits that absolute minimum and then goes back, either way, whatever shape this takes, there's always going to have to be some kind of minimum y value. The y values of an even degree are never going to go towards negative infinity for an even degree function with a positive leading coefficient. So with an even degree, positive leading coefficient, there will always be an absolute minimum. And then with a even degree and a leading coefficient that's negative, there's always going to have to be some kind of absolute maximum. Because again, the function is going to have to turn back because it has n behaviors from quadrant 3 to quadrant 4. So it might have a bunch of turning points and then hit that absolute maximum and then go down. Or the absolute maximum could be here or here. Wherever it is, there's going to be some kind of absolute maximum. The y values are going to be capped off with an even degree and a negative leading coefficient. And if you want to explain this in words as well, you can say an even degree function always has an absolute minimum or maximum because it has the same n behaviors. And you can also add the counterexample as well. You can say an odd degree never has an absolute minimum or maximum because it's always going to have opposite n behaviors. So the y values eventually will always go to positive and negative infinity.